Hello guys, welcome back to Medzone African Motives, still on Mechanotechnics N5, working on our revisions. We've got question number 4 of April 2023 that we shall consider. Take note there we are given on question number 4, that is an epicyclic gear train as shown in Fig 1 as the sun gear with 24 teeth and the planetary gear with 35 teeth each. All right, so these are the planetary gear that we have. P, that is for the planetary in this case. Remember, this part I think now we are used to the formation in this case that we have. Then we've got our A, which is the ring gear in this case, or the annulus in this case. We've got our ring gear or the annulus. Then we have got the sun gear inside here. Then L is representing the arm. So this is our arm in this case, all right? So we are given the number of teeth on the sun gear in this case here. The sun gear has got 42 teeth. So here we've got 42 teeth, and also the planetary 36 teeth each, all right? Meaning to say, yeah, 36, 36. So this is the planetary concept. As you can see, there are 3 of them. So in our question, the first part was to calculate the number of teeth. So the number of teeth on A, that is 4.12 marks for that. So for the number of teeth, this one is straightforward. We just need our formulas. We do not need even the table in this case for us to have this number of teeth. So what we are going to consider in this case is we've got, remember, we've got 2 formulas that we can use to calculate the number of teeth. We can apply the number of teeth in this case as the pitch center diameter over the module in this case, or we can consider the number of teeth from the formula that we have in our formula sheet. That is, the number of teeth on the annulus is equal to TS. So we are going to have the number of teeth on the sun gear plus 2 times TP, which is the number of teeth on the planetary. We are given this formula in our formula sheet. So as you can see, we do not have the pitch center diameter, the module. So this one is excluded for now. But if you are given that information, you can use it. But now we do not have this. We have the number of teeth on the sun, also on the planetary. So you can use this formula to calculate the number of teeth on the annulus. So this formula, you have it on your formula sheet. So meaning to say TA is going to be TS, the number of teeth on the sun, it's 42. So that is going to be 42 plus 2 times the number of teeth on the planetary in this case, which is 36. So we are going to multiply this by 36. All right, so that means our TA is going to give us something like 114 teeth. So we're going to have 114 teeth in this case. So that is it, straightforward like that, as long you've got the other number of teeth given. Therefore, you can apply that. Then on the other question, we are now asked here, if the arm L rotates at 45 revs per minute, calculate the speed and direction. Calculate the speed and direction of rotation of gear S, which is the sun gear, when the ring gear A, which is the annulus, is fixed. All right. This is a condition of a question, but remember, with this condition, even without this, we need to know the stages that you're going to have from our table of motions in this case. All right, so let us consider our table of motions so that we can calculate this given information. So I'm gonna have my table here so that we can see how this works, or how are we given this information in this case. All right, so let me just have my table, or let me just have my table first, then I'll explain from there. Right, so there we have our table in this case. So let us consider on our table. Remember, here we are going to need the number, then the condition. So we're gonna need our condition. Then let's consider the gears that we have here. Remember, we've got the sun gear, the annulus, the planetary. So I'm just gonna take from the outer part, the annulus, to the planetary, the sun gear to the arm. All right. So these are the only part that we have on your epicyclic. All right. So we said we have got the annulus, which is our gear A. Then we've got the planetary, which is our gear P. And also we have got the sun gear. And we also have the arm. So in this case, the arm is given with the letter L. So take note, our arm is L in this case. All right. So that is what you are going to have. So let us consider. Remember our steps, guys. The first thing that you are going to have is to fix the arm. Whether is this, it's always like that. You fix the arm, then you rotate the annulus, which is the bigger one. All right. So we are going to fix the arm. Fix the arm in this case. Then we rotate the bigger wheel. In this case, we are going to rotate the annulus. In this case, that is the gear A. +1 revolution. All right, so it's gonna be a +1 revolution. That is clockwise. Always the annulus, the bigger one, the biggest one, which is the ring gear, is the one that you consider, the one that will be outside. If it is a condition like this, you are going to consider this as your bigger one, and this is your bigger one. So you rotate the bigger one. All right, so that is what you're going to have. So let's consider now our calculations. If we are to rotate a 1 revolution in this case, all right, so it means gear A is going to have a +1. There's nothing that's going to affect because it is the one that is rotating 1 revolution, so it's going to be a +1. What about gear P, which is the planetary? Let us consider what is going to happen with the P as it is affected from the annulus. All right, so this is our P in this case. All right, this is our P. As we can see from this part, as the annulus in this case is going in a clockwise, it means our planetary also is going to be following the same way, which is the clockwise, opposed with the sun gear that is going to be in the anti-clockwise. So meaning to say here, the driven, which is the planetary, in this case, we are referring to the annulus, in this case, over the planetary, all right? So it's gonna be positive because it's going clockwise, positive, positive. So meaning here, we shall have the one that is being wrote AA, so it's gonna be TA in this case, which is the driven over the driver, both being positive, all right, over TP. So that is going to be the number of teeth on A. Remember, we have here the teeth on A is the one that we calculated. All right, we calculated, we got 114. So it's going to be 114 over the one for the planetary P. We listed this. We are also given P is 36. There are 36 of them there. So we're going to divide by 36. All right, so that is going to give us a decimal of 3.167, 3,167. All right, so that's 3,167. All right, what about the sun gear? What is going to happen with the sun gear? Remember, we said the sun gear is going in the anti-clockwise, but as it is inside this one, it's affected from the planetary. The planetary is affected from the annulus. So meaning to say we shall have that combination of the annulus and the planetary that we had before. And what was our combination? It was TA over TP. Remember, we had TA over TP from the previous part. Then now what is happening between the annulus, between now the sun gear now that is inside the sun gear and the planetary? What is happening? The annulus is going in the anti-clockwise, while the planetary is going in the clockwise. So it's gonna be the planetary, which is the driven in this case, which is going in the clockwise, over the driver, which is the annulus. The annulus, the sun gear in this case, which is our sun gear, is going in the anti-clockwise. So it's gonna be minus TS. So that is what you're going to end with. So as you can see here, these two are actually the same. So we are just gonna remain with TA over minus TS, but this was supposed to be the actual formula, this one. But as we can see, these two, they are canceling. So we can put it that way, or we can write as it is so that we do not confuse each other. So it's gonna be TA over TP times TP over minus TS. So as we can see, as we said, this and this will cancel. We remain with the TA. So we are going to remain with the TA over minus TS. So at the end, you see that it's gonna be A over what is affecting. It's here is supposed to be A over A over A. A is affected by A, so A over A gives us a 1, all right? So that is, if you check at the end, that is gonna happen like that, all right? You are talking about A, so the answer is supposed to be TA over TA. We are talking about P. P here is the one that is affected, so it's affected by what? By A. So it's supposed to be TA over TP, but now you consider the direction of P. It's also clockwise, so it's clockwise. C is S is going to be the same for S. It's going to be what is affecting A, so it's going to be TA over TS, but consider the direction of S. S is going in the anti-clockwise. It ends with the negative. If you just understand it this way, you are done with this epicyclic gear trains. We are done. That is the idea there. All right. So anyways, let us substitute our values. Our TA in this case, what is our TA? TA, remember, it's 114. So it's going to be 114 over minus TS. Our TS is 42. So the sun there, it is having a 42. So that's negative 42. So if we are to simplify, we are going to obtain a negative 2,714. All right, negative 2,714. What about the arm? For the arm now, it's fixed. Fix the arm. The arm is fixed. The arm, which is our L, it's fixed. So that one is, there's no way it's at 0. There's no movement there. There's nothing that is happening. So it's at 0. So these gears, that's how you can deal with them. If you want to be quick enough, when you do not understand this canceling part, know that A must affect what is affecting at that moment, A versus A versus P, A versus S. But go back to the diagram and check the directions now. The diagram is the one that is going to give you the directions. All right, so anyways, at this stage, this is the first, it's a fixed, I said this one, it's a fixed condition on each and every gear drive that you're going to have, epicyclic gear drive that you're going to have. So the second condition is going to be what? The second condition is whereby you have to multiply by X, then add Y. So we are going to multiply by X, all right, and add Y. And we add Y in this case, all right, and we add Y. All right, let me just try to shorten so that it can be accommodate everything. Add Y. So let us just be direct. Multiply by X, add Y. So to add plus this, you multiply it by X. So it's gonna be 1 times X. Whatever that you get, you add Y. So 1 times X, it's X. So it's gonna be X plus Y. The same with this value here as it is, you multiply it to X. The first condition is to multiply. So it's 3,167. Multiply it to X. Whatever that you get, you add Y like this. So at the end, you're gonna see you're gonna have 3,167X plus Y. The same thing, multiply this value by X minus 2,714X. We have multiplied by X, then we add Y. 0 times X, that's gonna be 0X plus Y. So 0 times X, that's a 0. So 0 plus Y, we are going to obtain a Y there. All right, so that is another fixed stage again that you're going to do after this. You multiply, these are the stages that you're supposed to follow as they are. The last part now, this one is the condition from the question. It's a condition that you take from the question, from the given question, from the given information. That is the question now. That is where we go back to the question. What is the question saying? The question is here. This is our question 4.2. Let's read the question. If arm L rotates at, we are given the rotation of arm L being a positive. So we have the speed of L in this case, which is at what? At 45 revs per minute. That is what we are given now. We are considering what we are given, a positive. calculate the speed and direction of rotation of gear S. We are supposed to calculate the speed of gear S, which is the sun gear. So we do not know this speed of gear S. We do not know this. When ring gear A is, that is A is now fixed. No, not to say the arm was fixed. No. It's another part that we are dealing with. The gear A is the one that is fixed now. So meaning to say gear A is no longer moved. There's no movement on gear A. Gear A, there's no movement. So it's at 0. It's fixed. So the gear A, it's fixed. That's the speed is going to be 0 revs per minute. Is there anything that we need? Nothing, because we have got this for the L, we need for L, we need for S in this case, and what is happening at A is at 0. The planetary, in this case, we do not have the information, and there's nothing. So this one, we just exclude this one, and we do not have information. We just exclude this one. All right, it's affected. These are the ones that are affected. These are the ones that are affected at this moment. So what do we have here? We are going to simply substitute. A, we have A is what? At 0. So this one is a 0. All right. S, as we said, is the one that we want. Remember, S is the one that we want. So we need the speed of S in this case. This is the one that we are supposed to calculate. What about L? L we have for the arm. They told us the arm is rotating at 45. So the arm here is at 45. That is how you answer this question. You are done. With this table that you have, or with this information that you have now, we are now asking ourselves, how can we calculate Y? How can we calculate our speed S in this case? So let us consider what we have here. We are going to equate these two. That means we are simply saying X plus Y is equal to 0. You form equations now. X plus Y is equal to 0. We have formulated an equation. Here, there's nothing that you're going to equate. You move on to this part. It means this NS, which is our speed, our NS, the speed for the sun gear, is equal to this part, minus 2,714x plus what? Plus Y. So by finding this, by finding X and Y, we can substitute them into here so that we can calculate NS. We move on to the last part that we have. Y is equal to this part, which is 45. So we have the value of Y in this case to say Y is equal to 45. So that's another equation that we have. So if Y is equal to 45, what about X? It's just a direct equation, this one that we are simply, because it's not like, yes, these are simultaneous equations since we are solving for X and Y simultaneous, but already here we are given that Y is 45. So just substitute here. X plus Y is equal to 0, and Y is given as 45. So X plus 45 is equal to 0. So X is equal to what? That one, it becomes a negative on the other side. So we have the value of X. We also have the value of Y here. So therefore, what is the speed? Because we have the equation for the speed. So our NS is going to be negative 2,714 times X, whereby our X is negative 45, plus Y, in this case, Y being what? Y being 45. So this is going to give us the speed of the sun gear in this case. So if you were to simplify properly, we're going to obtain something like 167,13, which is the speed in revs per minute. So that is how you play around this table. The first step, like I always say, draw your table properly, mention your gears, all the gears that are part of the epicyclic gear, and also the arm. The first part is to fix the arm. You rotate the bigger gear wheel in this case. So we are going to rotate the largest gear wheel. In this case, the largest gear wheel is the annulus, always like that. Then the second part is to multiply by X and add Y. Then the third part here and the fourth, maybe they can be the fourth one depending on the conditions. These stages now, you use this condition of that is, you take from the question, you take from this question that you are given. What are you given? What are you asked to calculate? You do not use this information in the first place to say, what am I given? What on this? No, there it's a follow-up. These are the stages that you're supposed to take. Follow-up stage. Then this one is from your question. Formulate simultaneous equations or whatever equations that you formulate from there. Solve for x and y. Sometimes it might be direct, whereby maybe it's given that direct ns is equal to y. There's no need for you to solve an x and y, just solve for x. But if you are given a condition whereby your ns, it consists of x, it consists of y, therefore there you are supposed to solve for x and y. So that's what we had, guys, from Maison African Motives. Till we meet again.